Hello and welcome to my channel. In this video I'm just going to quickly test various different types of cables, USB-C and USB-A to C, to see what kind of voltage drops they experience. This thing has gone to sleep again. It goes to sleep very quickly. I'm going to use the same power bank throughout. This is the one made by VEEKTOMX. I'll put a link in the description, or the name at least. And this is my tester box, which displays voltage and current. If I switch on a load, it caused a gap in the output. That's not very clever. That's a 1 amp load current flowing. And you can see that with this USB-C cable, the voltage drops from 5.11 down to 5.05 volts maybe, which is not bad. That's what, 60 millivolts. Quite a small drop in voltage, but it's a very short cable. That's 10 centimeters long, and it's USB-C. And inside this box is a decoy module or a trigger module that's set to 5 volts. It has dip switches on, so you can choose the voltage you want to demand from the power supply. And I'm not quite sure still how USB-C really works, power delivery. So when the board says to the battery or power bank, I want 5 volts, then the power bank generates 5 volts, as you might expect. What I'm wondering is there any voltage measurement at this end of the cable where if the voltage dips too low, it sends a signal back to the power bank and says, hey, up the voltage a bit, please, because I still want 5 volts here and it's dropping voltage on the cable. I don't think it's that clever. I'm not sure. And I've tried a number of different cables, and they all give pretty much the same results. Where are the cables that I tried? These ones, these are all USB-C to USB-C cables, and various lengths, various thicknesses. Some have got fuzzy felt on them, some are a bit rubbery, and they all give pretty much the same results. As you'll see if we look at my table of results, I'm not going to make you sit through watch me testing all those cables. I just turn off the camera, and then we can see this is my results for USB-C to USB-C cables. So with no load applied, there was 5.11 volts indicated on the meter. I can't guarantee that's correct. It could be wildly wrong. I've got nothing to calibrate it against, so I'm just hoping it's roughly correct. But certainly for relative differences, then you can see what's happening. And the cable I just had connected is 10 centimeters long. Last time I measured it was giving 5.01 volts with a 1 amp load. So yeah, that's a 100 millivolt drop. And you see that most of these cables that I just showed you give roughly the same voltages. There's very little difference in the voltage drop along the cable until you get to this one, which is 2.7 meters long. So it's quite long compared to 10 centimeters. And you can see that there is a more significant voltage drop, which suggests to me that the USB-C standard doesn't report back and say, hey, I've only got 4.85 to the power bank, give me a bit more please so I get closer to 5 again. I don't think it does that, unfortunately, but it still is a fairly consistent set of results. What I'm going to do now is go back to the more old-fashioned types of cables, which are often used, and these are USB-C plug on one end and USB-A plug on the other end, the older standard. And what I've done is I've chosen the best one. And is that the worst one? No, it's not actually. The worst one is somewhere else. Typically, this is the worst one, which is the same length as the best one, almost best. Anyway, for some reason, this is the cable that comes with the WISBlock rack board, and they supply you with a USB cable. It's quite fat and it's not very flexible, and this is the one that actually gives the lowest voltage drop. Which is nice to know. How am I going to test these? Let's just unplug the USB-C stuff. Take that out as well. So this is, let's start with the worst. This is actually the worst cable. I'm going to plug it into here. USB-C input, and the USB-A end is plugged into the power bank. And it seems all these power banks, the USB-A output is a lot more variable than the USB-C one is. So that's putting out 5.1 volts, and if I load it 1 amp, you can see the voltage drops down to 4.45 volts, so that's more than half a volt drop. That's 10% along this 10 centimeters of thin cable, which is indicating that the cable is, depending what you want to do with it, could be quite useless. This is the sort of cable I put into little boxes when I build meshtastic or reticulum nodes. it's nice to have short cables with quite short plugs on to connect all those little boards together in a tiny box. You wouldn't want to put something like this inside a box and try to cram it in because it's too long, too fat, and the plugs are much longer. But the problem is if you do use things like this, and perhaps you're supplying a Raspberry Pi with 5.1 volts it needs, and if the thing decides to take 1 amp, which is not outside the realms of possibility, then that voltage will cause the computer to crash and it won't run. So that's a serious problem just because of the cable. And they don't write on the cables what the resistance is. I've taken some apart because I've extended them or changed the plugs, and some of them I've noticed have very thin wires like hairs inside, which may be okay for carrying data and small currents, but not much else. So it goes from 5.1 down to 4.45. Goodness me. And if I plug in the best cable, the one from the rack node, I think it goes this way up. Yep. See what this one does. So 5.11 volt open circuit voltage, which is what we'd expect, and if we switch this on, it goes down to 4.94 volts. So that's like 50 millivolt change, not half a volt. So it's 10 times less voltage drop along this longer cable, which is probably 1 meter, than along this 10 times shorter cable that's way too thin. A huge difference. So if you're running a Raspberry Pi on this cable, then it probably wouldn't crash when you load it, although that's also a bit low. I'm experimenting with boost converters to try and up the voltage and regulate it better from these sorts of power sources. I won't test these in-between cables because they are somewhere in between. What I can show you is the list of results that I've got. I turn off the camera again and we look at this list. So this is USB-A to USB-C, and there's the cable from rack, 100 centimeters, and with 1 amp flowing, that's the voltage, which is not much less than 5 volts. But as you go along down this list, you see the voltage dropping lower and lower. This is a 1 meter cable, 4.76, 4.74, and then I've got the one I showed you at the beginning, 20 centimeter long, very thin black cable, 4.48 volts, which is useless under some circumstances if you want to take 1 amp through it. So that's quite an eye-opener, I found. The other thing I tested was these extension cables, and I'll just show you quickly what they look like. I'm sure you've seen one before, but let's have a look anyway. My extension cable collection is here. We can move this out of the way now. There's a Raspberry Pi in a box, heatsink, passively cooled. And what I discovered was that the cables that have the furry coating, that are more flexible and lovely, have the highest voltage drop, so they're the worst cables. This one is particularly bad. This is the bottom of the pile. I'm starting at the bottom, and it looks nice with this black and white checkered fabric coating. These are all from Amazon, but it's actually the one with the biggest voltage drops. They're all different. This one is, I think, the worst, almost, in that length. It's 1.8 meters long, and I only bought these extension leads because I wanted to cut them up and put them through a hole in the wall. But the voltage drop is just too big, and things don't work. Especially if you're using SDR receivers that take quite a lot of current, the SDR dongles, then you have to put a decent cable on, and this is no good for that. This one is a kind of a joke cable from Amazon. They don't stock this one anymore. It's a 10 meter long USB-C to USB-C extension lead, and on the page where they're selling it, they say, warning, this cable does not work. Don't use it, don't complain, it's not going to work. And indeed, you'll see when I show you the table of results, it has a huge voltage drop and probably doesn't get much data rate through reliably, even at 480 megabits. So that's kind of a joke cable. Maybe I'll cut the plugs off and use them for something else. The other thing I got is these wire adapters, 2 different ones. There's a grey furry one, which you should know by now is not as good as the black rubber coated cable. We'll see in the results they're different. This is the black splitter or Y cable, and this is the grey and white furry one, and they give quite different results. What I want to do is plug this into a power bank and then power 2 different devices from it. So let's have a look at my results. Excuse me. So that's here. So these are extension cables. So I used the lowest loss cable that I had, which is a white one, 15 centimeters long, and with 1 amp flowing, it was giving 4.94 volts under load. And then putting on different extension cables, you can see the voltage dropping down and down. that 10-meter long cable, 3.65 volts at the end, that's nowhere near 5. I mean, that's really trash. They don't sell it on Amazon anymore. If you click on the link, it says page not found for obvious reasons. I expect they're all sent back except my one. The splitter, these Y splitters, the grey and white one actually is better this time, 4.73 volts, but it's still nowhere near 5. And the, wait a minute, grey and white, and where's the other splitter? Oh, it's up there. Yeah, that was the worst, the grey and the white. So the fuzzy, furry cables are worse. And the one with the black rubbery coating gives 4.85 volts, so that's like 120 millivolts more. Still a lot less than 5, so this is really not good. It means that none of these extension cables really can be used if you want to take 1 amp through them at 5 volts, because the voltage drop is just too much. And I don't think it's the power bank that's dropping the output voltage. I've checked that with another inline checker. The voltage stays the same at the power bank end, but at the load end, then you get these lower voltages. So there really is voltage drop occurring on the cable. And there's similar lengths to the USB-C cables I tested, up to a meter or a bit more, but these give far less voltage drop. So this shows why the USB standard, or one of the many reasons why it was invented, because you get far less voltage drop when you try to take some power through the cable. And some of the cables I use have got 100 watts max, or even 140 watts. I think one of them says stamped on it to say you can do fast charging. Seems like a lot of power to put through a thin cable. But anyway, certainly they have low resistance, or the USB-C standard is able to compensate better for voltage drops, which this USB-A standard isn't doing. So perhaps somebody could let me know if there really is feedback to keep this voltage constant, or whether there isn't. You can see there's certainly no feedback going on here. So that's what I wanted to say. With these cables, you really have to watch out with the quality of them. And of course, when you buy them, nobody tells you what the resistance of the wire is, unless you read the comments and somebody's actually tested them. It's a lottery. It's a lucky dip. Or in this case, with extension cables, it's an unlucky dip, because it's hard to find anything that even this short splitter cable is causing a huge voltage drop, and it's only 15 or 20 centimeters long at the most. So this doesn't look good. I think the thing to learn here is don't use USB extension cables ever, and use good quality cables, and preferably not USB-C, but not USB-A, but use USB-C cables to give the lowest voltage drop. And of course these ones are the more expensive ones, but I think it's worth it if you're expecting equipment to work. Anyway, that's enough from me, so I'll stop here. Look forward to reading your comments and questions, and let me know how you're getting on with supplying power to remote radio nodes from batteries that are solar charged over pieces of cable. Thank you for watching, and I'll see you in the next video.